Hey, what's going on today, YouTube? Today we're going to be going over Index TTS2。我其实没有真的在说中文，而是用这个模型把我的声音转换成中文来做演示。So now that we're back to my voice here, I'm going to show you guys it real quick, just a little demo, talk a little bit, and then I'll show how you can install it. Okay, so that little Chinese portion there, that entire sentence at the beginning was actually just done in Index TTS2. So I have my prompt audio here. I've got the sentence, half English, half Chinese, and then you've got the output. So this is the input audio. Hey, what's going on today, YouTube? Today we are going to be going over Index TTS2. So I'm not actually speaking Chinese, but I'm using Index TTS2 to use my voice in order to do so. And then here's the output. Hey, what's going on today, YouTube? Today we're going to be going over Index TTS2. 我其实没有真的在说中文，而是用这个模型把我的声音转换成中文来做演示。And then I just processed it using an RVC version of my voice just to get it sounding a little bit better. Hey, what's going on today? So there you go. It's a little bit higher fidelity there. And that's just a common trick that's used. So this is pretty neat. Index TTS2 has seen to be pretty good at like dubbing. And this ability to do dubbing is probably why I was excited for Index TTS2 to be released. I also have an example to show you guys. So I dubbed a portion of an anime. This is from Vivi. So if you haven't seen the anime and you don't want spoilers, well, this is from episode 7. But this is a kind of a nice demonstration. I dubbed this entire sequence with Index TTS2. So we'll go ahead and take a listen to it.
Why did you call me Vivi? Why do you keep saving me? Why did my body move of its own accord? Do you know about the person inside me that I don't know? Ever since I was rebooted ages ago, something's been bothering me, again and again. But exposing those misgivings would affect my singing! That is why I've kept a lid on those doubts all this time. And it is you who just opened that lid now! Surely, it must be something precious.
Everyone is waiting for you. Why don't you return? Songstress Diva?
Fine. Then I'll ask another question.
Another one?
Nice try. I figured it out. There was a young guy, remember?
Hold on a second! A guy? Who would that be? Did he know about you?
You don't know?
Answer me, please!
And now you expect me to tell you, even though you refuse to answer my questions. There isn't much time, you know. Like you said, I'm keeping everyone waiting.
You and I, we both had done the same work before. Back when you went by the name of Vivi.
So there was that sequence there. I think it's fairly good. Like if I didn't know the context, I would be convinced that this is probably like the dub portion of this. And so, yeah, I'm going to go and show you guys how you can go and install it and all of that good stuff today. So we are going to hop straight into it. And this is the repository right here, but you're going to need a few prerequisites. One is you're going to need an NVIDIA graphics card to run this. And then a few software packages installed on your computer. So first thing is you're going to need UV Astral installed on your computer. We're going to use this to manage Python. So what we can do is just go to this link here, copy, and then we'll just open up, let's just say PowerShell, hop on in here, paste, and then enter. And then so this will show up once it's done installing. Then we'll just click on this X here to close out of the terminal. We're going to want 7-zip on your computer. So just go to download here and then just go through all of the default options. And then we're going to want Git on your computer. So click here to download for Windows. Go ahead, go through all the default options for the installer for Git. So I'm going to go ahead and cancel this because I already have it installed on my computer. Just go through all the default options for that. And then I'm going to show how you can get FFmpeg installed on your device too. So this is going to be needed for some audio processing. So go over to this link here, gyeon.dev, and click on this FFmpeg get full.7-zip file. So go ahead and download this one already. I already have this in or I already have this one downloaded. I had actually done this video before, but my data crashed, so I'm doing it again right now. But once you're done with this download, you should have 7-zip on your computer, and so that's what we did earlier. So just right click, go to 7-zip, extract to FFmpeg full build, and this should extract to that folder. I've already extracted it. And then you'll be left with this folder here. So my recommendation is click F2 or rename, and let's just call this FFmpeg. And then what we're going to do is just move it. So copy and go into this PC, local C drive, and paste it here. So, if it says you need admin access to paste it here, then just say yes. So we're going to paste it here. And then what we're going to do is go to the address bar, or actually double click into FFmpeg, double click into bin, go into the address bar, right click copy, and then we're going to go into our environment variables. Oops, just type in env where it says edit the system environment variables. We're going to go into environment variables here, go into our path, edit, new, and then we're just going to paste that address bar into here. But what that's going to enable you to do is allow you to call FFmpeg from the command line and allow for all the other software on your computer to have access to it to process audio correctly. So those should be the 4 things that I believe you need for this. So now we'll go ahead and jump into getting this repository downloaded and installed. So we're going to go into the green code button, go to copy URL to clipboard. One thing before that, on this left hand side here, go into the YouTube branch. You'll be on main, but go into the YouTube branch. This is where all of the code is that I'm using for this YouTube video. And then now go into the green code button, click on copy URL to clipboard, and then navigate into the file browser and go to anywhere where you can find that you can find easily. And then we're going to go into the address bar, type in cmd. It's going to open up a terminal here. And then we're going to type git clone and then paste that link here. So what that's going to do is clone index.tts into the folder so that we can get access to it. And then when that finishes up, we're just going to change directory cd into index, and I'm just going to use tab for completion and then click enter so that we're inside of that directory. So now we're in here. You should have UV installed on your computer. Actually, before all of that, I'm doing this while I'm editing. You need to do git switch YouTube, and that's going to switch you over into the YouTube branch. Sorry, git switch YouTube. Make sure you spell that correctly, and you'll now have this set up. We're just going to type in UV sync, and what that's going to do is create a virtual environment with everything that we need. I already have everything pre-cached here, so it's going to finish up for me. All right, and once that is done, head over into the GitHub repository. There's actually a bunch of commands here that we could run that I totally forgot about. So we'll just go here after you did UV sync. Right click copy and go back into that terminal browser, paste, and we're going to do that to get the checkpoints downloaded into the repository. So these are the model weights that we're going to use for the inference process. If you want to know where they're coming from, you just scroll a little bit down, go to Hugging Face. This is the repo here, files and versions. You can download all of these manually, but that command will get it up and downloaded for you guys. And once it finishes, all of the files should be inside of this checkpoints folder here. If you do run into any issues with the download process and you run into issues with inferencing later on, it's possible there was some type of downloading issue with Hugging Face where the files got corrupted. So you would just need to delete all of those files and re-download them. I'm saying that because that happened to me, but for this case, we have probably been successful. So lastly, all we need to do is just copy this last command, which is uv run the web UI parallel, and that should be all good to go to get it up and running. So this here is a different type of Gradio interface that I ended up making because of a certain use case that I had with it. So there's some additional features in there that I won't be going over because it's very niche. So I'm not going to explain it too much, but it's going to take a little bit of time to start up the browser here. I should also say, if you go into your task manager, you can see how much VRAM this uses by going to performance and going over to your GPU. This PC has a RTX 3060 12GB version, and so when it loads up into here, we'll be able to see how much it's using. All right, so the web UI has loaded up, and we can see it's using about 9.3 gigabytes of VRAM. So an 8 gigabyte VRAM card will not be able to run this, unfortunately. There is a way to reduce the amount of VRAM you're using by launching it with FP16, but I'll show just the model real quick, and then I'll show how you can relaunch it with that later. That should be pretty much it. So we can do left control and then left click, and it should open up here. We'll need to change this on Windows at least to be localhost, localhost colon 7862, and you'll be met with this interface right here. So we can go ahead and just click on one of these examples. So I'll click on this first one here. Make sure you click on one of these emotion control modes. I'll show you real quick what happens if you don't. If you go to click generate, you'll get this value 0 type error. So just make sure you've selected a emotion control mode, and then we can just regenerate with that. So the VRAM usage will go up during inference. So we can see that it jumped from about 9.3 to 10.3 for this run. And then we can listen to the output here. Give me one moment. Okay, so here we have the computer, and we can just play the audio out loud.
Translate for me! What is a surprise?
Okay, so there you go. It's able to do the inference, and it's at about 10.4 gigabytes of VRAM. I believe if we use a longer sample here, once again, the match prompt audio. I believe if we use a longer sample here, it does end up utilizing more GPU memory. So now you can see it's starting to jump up to about 11.5, and I think we'll start to get VRAM out of memory issues with any longer bits. So if you go into advanced generation settings, you can see how many tokens it's going to use. So in this case, we have a total of 203 tokens for this, and this is Chinese here. So there you go. So let me just show you guys real quick how you can relaunch this with the FP16. And so if we go into here, you can see the VRAM usage has dropped back down. So if we just click up key on the keyboard, it'll get the last command, and then we could do double dash is underscore FP16. And that's going to now launch it with floating point 16 for loading the weights, and it's going to use less VRAM here. So instead of about 9.3 on launch from last time, now it's at about 7.9. So you reduce it by about 1.4 gigabytes of VRAM. We can reload this here, and we'll inference on that same file. I think it was this one here. Match prompt audio, generate, and we can see how much it jumps up to. So the previous generation topped out close to around 11.5, I think. And so now this tops out at about 9.1 for 20 seconds of audio. So yeah, this is usable on a 3060 12GB. The iterations per second ends up being a little bit slower on FP16, so about 7 iterations per second. I think it's a little bit faster without FP16. Okay, so that is how you can pretty much just get it up and running on your own computer. This one is a 3060, so yeah, you can get it installed on devices that have 12 gigabytes of VRAM. And now we'll go and jump into some more littler or smaller details like advanced generation settings, stuff like that. So for that, I'm just going to jump into my main computer, and we'll do that here. So I have this launched up already. If you're running on a higher card, you'll get closer to around 60 iterations per second. So like a 5090 or like a 4090, you'll probably get closer to about 40 to 50 iterations per second. It's pretty quick. It's faster than real time. So if you want to, let's say, do zero shot voice cloning, you need to just upload a piece of audio in here. So you can use Audacity to cut up and split out clips. And then you can use something like UVR to get out any background noise if you have files that have background sound. But for this, I'm just going to clone my voice here. So I'll go ahead and go into this mic setting and just start recording my microphone here. So I'm currently speaking into the microphone to be captured for zero-shot voice cloning. And then so I'm going to go ahead and stop that here and we can take a listen. Start recording my microphone here. So I'm currently speaking into the microphone to be captured for zero-shot voice cloning. So there you go. Not the highest of quality for that capture, but it'll suffice for what we need here. And then we could just let's just take this here, just some random text, and then I'll paste that into here, and generate. And we should see this takes a couple of seconds to finish up. So there we go. So let's take a listen to it. I'm not actually speaking Chinese, but using this model to convert my voice into Chinese for demonstration. So there we go. It's good, but I think it could be a little bit more accurate for my voice in particular. But what you might notice is that the resolution for this matches fairly close to the input audio. So start recording my microphone. So that isn't as clear as I would like it. So one thing, if you want to have better quality audio, is make sure your input prompt audio sounds a little bit better and higher fidelity. So if I just drag in one of these samples here, a little bit higher fidelity, and we can take a quick listen.
I also watered it this morning. It's a small change, but sometimes little adjustments make a difference.
And then we can just generate it on, and take this here, and then we can take a listen.
In my younger and more vulnerable years, my father gave me some advice that I've been turning over in my mind ever since.
So there we go. The output quality from here is a little bit higher fidelity, but it's not, let's say you have like a 40K hertz input audio. It's still only going to output in 22.050 hertz. So it's going to be lower fidelity. There are ways you can upscale it after that, but that's a little bit beyond this video. I did use an upscaling process to for that anime dubbing that I did a little bit earlier. But I won't go into the details for that right now. So yeah, pretty much the sky is the limit here for prompt audio. Now I want to show that you can also change the emotion vector here, which allows you to exaggerate different emotions inside of the audio. So the audio file here is closer to more of a neutral voice, but we can spice it up a little bit and add a bunch of anger into there. And so I'll crank it up to 1.2 for anger and then click generate so we can start regenerating here. So we'll wait for it to finish up, and here we go.
In my younger and more vulnerable years, my father gave me some advice that I've been turning over in my mind ever since.
So there we go. I don't know if I'd call that angry, but probably, yeah. Definitely more exaggerative. We can crank up the sadness slider here. Let's see, like 1.4.
In my younger and more vulnerable years, my father gave me some advice that I've been turning over in my mind ever since.
So that is definitely much sadder. That one was actually pretty good in my opinion. And then, we could probably let's just throw in fear here. So generate with that.
In my younger and more vulnerable years, my father gave me some advice that I've been turning over in my mind ever since.
So that is also really good. And so that is the strong point of Index TTS, is the emotion or the ability to capture emotions fairly accurately or adjust and change the emotion vector to your own liking by dragging these sliders. Now, there is one thing you should note. You cannot have a cumulative emotion vector greater than 1.5. So we've got all of these at 1.4, 1.4, 1.4. It says the emotion vector sum cannot exceed 1.5. So you need to make sure that the total accumulation of the values here do not add up to more than 1.5. So you could do like 0.1 and 1.4, and this will generate just fine. Now, how I did that anime example a little bit earlier, I'll show how I did that. So this is the strongest point of Index TTS2, I believe, which is matching the prompt audio and being able to use that as guidance for the output example. So in this case, I had a a snippet from the anime. We have it in Japanese, and then we just needed the subtitles for the exact audio sample. So here is the sample.
どうして私をビビと呼んだの？どうしてあなたは私を助けるの？どうして私のボディは勝手に動いたの？あなたは知ってるの？私の中の知らない私を。
So that is the full prompt audio there, and this is the text in English, and we could just generate with this. And so what we hope is going to be achieved is this input prompt audio is going to be captured for the output prompt audio for the same type of emotion. So we can take a listen to it now.
Why did you call me Vivi? Why do you keep saving me? Why did my body move of its own accord? Do you know about the person inside me that I don't know?
So there we go. Now I would probably do a few more generations with this, change a couple of these settings to try to get one that's a little bit more accurate and closer to 15 seconds. So then I would jump into the advanced generation settings. I found that increasing the temperature vastly changes the quality of the output sentence in terms of expression and prosody. And then I'm not too sure exactly what the top P, top K, and the number of beams are doing here. But let's say that it's speaking too fast. What I can try to do here is reduce the max tokens per second. Reduce the max tokens per sentence to about half of the total tokens that we're inferencing on. They added up to 55. So yeah, we decrease it to let's say 32. We don't want to split it into 3, but just split it into 2. So what we're trying to do is make it a little bit slower. So you can reduce the max tokens per second. So this outputted at 0.12. Let me revert temperature real quick, just to show you guys. So we just reduce the amount of max tokens per second. And I've found generally that the output of the sentence is going to be a little bit slower. So here we go. We've got 13 seconds, so a little bit longer.
Why did you call me Vivi? Why do you keep saving me? Why did my body move of its own accord? Do you know about the person inside me that I don't know?
So there we go. And yeah, we can just keep reiterating, doing all of that fancy stuff. Like I said, if you increase the temperature, it kind of changes how dynamic and kind of random the output is. I found that it adds a little bit more expression to it. So we could take a listen to it once it finished processing here.
Why did you call me Vivi? Why do you keep saving me? Why did my body move of its own accord? Do you know about the person inside me that I don't know?
So this one is closer to about 15 seconds, but as you can see, like in this middle part, we had a little bit of excessive breathing, I would say, for the output audio. So I wouldn't be able to use that. But yeah, this is kind of the process that I went through in order to get the samples that I needed to do for that dubbing video that I showed a little bit earlier. And then of course I did some post-processing. I used UVR to isolate the background track to overlay or underlay it underneath the output audios here. And then what I used was an audio upscaler to increase the quality of it from 22.050 hertz to 48k hertz. So I think I've shown this repository before in the past. APBWE, it can be used to upscale some of the voice samples. So for example, here is the first sample that I used in that anime video here.
Why did you call me Vivi? Why do you keep saving me? Why did my body move of its own accord? Do you know about the person inside me that I don't know?
And this is how it sounds after being upscaled.
Why did you call me Vivi? Why do you keep saving me? Why did my body move of its own accord? Do you know about the person inside me that I don't know?
So I think the video for that is somewhere gonna be here. I'll pop up on the screen. But yeah, that is going to be pretty much it for Index TTS 2. I feel like I talked a little bit more on here, rambled kind of on some extras. Probably because I haven't created a video in a while and I've just been playing around with a lot of stuff. So yeah, that's going to be it for the installation video. And yeah, once again, if you guys have any questions about it, please feel free to leave a comment down below. I've been fairly busy with just checking out a bunch of things like Quen. I've been trying out a lot of the Quen stuff and been kind of just encaptured in trying out some of those new models they're releasing. And then, of course, Vibe Voice and then Index TTS 2. But yeah, once again, if you're a member of the channel, I very much appreciate it. And as always, I will see you guys in a future video. So catch you guys later.